Okay, so welcome to Quadratic Equations. So let's start with what actually are quadratic equations. Before going on to the definition, I would like you all to solve the following equation. That is x square minus 5x plus 6 equal to 0. Let's take another equation, say x minus 2 whole square is equal to 0. Let's take another one, say x square equal to 0. So what are the solutions for each of the equations? For the first one, from whatever we have learned in factorization, what we are trying to do is this, that we will split 5x such that the product of the factors in which we split 5x is equal to 6x square. That is x square minus 3x minus 2x plus 6 equal to 0. So here the product of minus 3x and minus 2x is equal to 6x square. Okay, so what we are making sure is that the product of this into this, that is minus 3x into minus 2x, is equal to 6 into x square. So now this is the right way to factor a quadratic equation. Now we take x common from the first two terms and write x minus 3 plus, now we take minus 2 common from this and this term and write x minus 3 again, because if you take minus 2 common from this, x minus 3 is what you will get, and this whole is equal to 0. Now x minus 3 is common from the whole expression, so I take x minus 3 common from the whole expression, and what we get is x minus 2. So in the end we get x minus 3 into x minus 2 equal to 0. This tells me that x has two values, 3 or 2. Now why do I write or here? Because my ultimate goal is to satisfy this equation. So this equation will be satisfied if x equal to 3, because then in that case this will become 0, the first entity. If x equal to 2, then this second entity will become 0. And product of any number with a 0 is 0. So that's how x equal to 3 or x equal to 2 both will satisfy our equation. Now let's try to solve the second one. That is x minus 2 whole square is equal to 0. In this, it's straightforward. On putting x equal to 2, we will get 0 square, which will be equal to 0. So x equal to 2 is the solution for this. For the third one, that is x square equal to 0, once again we have x equal to 0 as the solution. Now see, the problem here which we are having is that for this equation we had two solutions, but for this and this we have one solution only. Now by rule, number of solutions of an equation should be equal to its degree. Now degree of an equation is the highest power of the variable in the equation. For example, in this equation x square minus 5x plus 6, the highest power of a variable, that is x, is 2. So this has degree 2. In this equation, once again, if we expand x minus 2 whole square, we get x square minus 4x plus 4 equal to 0. So once again, this is an equation with degree 2. Similarly, this also is an equation with degree 2 because once again the variable x has the highest power 2. Now, by our rule, the number of solutions of an equation should be equal to its degree, which is okay in this case, but not okay in this case because here we are having only one solution while the degree is 2. And same here, we are only having one solution when the degree is 2. So what we do in these cases is that we make two solutions of this by writing like this: x equal to 2 or 2. We say that it has got two solutions and the value of the two solutions is 2. Similarly, we say that this equation also has got two solutions and value of both the solutions is 0. So that makes me have two solutions for each of my equations with degree 2. So now quadratic equations are the equations with degree 2. With degree 2. In this video, we will be covering various type of quadratic equations and the ways to solve them. Okay, so now as we defined in the rule, I can also define the same rule like this, that any quadratic equation should be of the form ax square plus bx plus c equal to 0, where a, b, comma c can be any numbers. The only restriction here is that a is not equal to 0. Why? Because if a is equal to 0, the degree of this equation will reduce from 2 and will become 1 or 0 depending on the value of b and c. Suppose a equal to 0, then this equation becomes bx plus c and the degree 2 doesn't stay true anymore. That's why we just have a condition on a, that is a not equal to 0. Other than that, a, b and c can be any numbers. So that's how we define a quadratic equation. Now let's come to how to solve the quadratic equations. Now here in this case we took examples of the above quadratic equation. I would like you to try solving this. X square minus 36x plus 323 equal to 0. Please try solving this. Now I am sure for most of you, you must be wondering that how to split this so as to the two constituents which you get, their product is 323x square. Like you can split it, say 28x and 8x, minus 28x and minus 8x, that is, but their product comes out to be 224x square and not 323x square. So it is not the right way to split. So in that case, I would say that in order to solve quadratic equations, that is not just the only way. That is, splitting the middle term is not just the only way. There are two other ways which you can try to solve a quadratic equation. First way is which we call quadratic formula. Now the quadratic formula says that x equal to minus b plus minus root of b square minus 4ac by 2 into a, where a, b, c are the coefficients of a quadratic equation. For example, in the equation we are talking about, a is equal to 1, b equal to minus 36, and c equal to 323. Okay, so now let's quickly plug in these values into the quadratic formula which we are going to use. So it looks something like this. X is equal to minus of minus 36 plus minus 36 whole square plus minus 4 into 1 into 323 whole divided by 2 into 1. The result we get is 36 plus minus 1296, that is 36 square, minus 1292, that is 4 into 323 whole divided by 2, which is then equal to 36 plus minus root of 4 divided by 2, which is equal to 36 plus minus 2 whole divided by 2, which is equal to 38 by 2 or 34 by 2. So the solution which we get for this equation is x equal to 38 by 2 or 19, or x equal to 34 by 2, which is equal to 70. So now let's try to solve another equation using the quadratic formula. So first let's get rid of whatever is there for the previous equation. Yeah, so we are ready to go. Now let's try to solve this. X square minus 5x plus 8 equal to 0. Using the quadratic formula, we get capital A is equal to 1, B equal to minus 5, and C equal to 8. Plugging this in the equation, we get x equal to minus of minus 5 plus minus 5 whole square minus 4 into 1 into 8 by 2 into 1, which gives us 5 plus minus 25 minus 32 upon 2, which gives us 5 plus minus root of minus 7 by 2. Now as we see, here comes the problem. What is the root of minus 7? So root of minus 7 does not exist. So by this we can conclude that the given quadratic equation has no solutions, or if we call the solutions of quadratic equation as roots, then we can say that the given quadratic equation has no roots, right? So now since we have realized that this equation x square minus 5x plus 8 does not have any roots or no solution, and to realize that we plug the values a, b and c in this equation. But then if we look carefully, we would find out that b square minus 4ac, this is what matters for us to decide that whether a solution has real roots or no. Because if b square minus 4ac is negative, as is the case here, that is equal to minus 7, then in that case the equation has no solution. On the other hand, if b square minus 4ac is 0 or positive, then equation does have solutions. So what we realize from that is that if b square minus 4ac is negative or less than 0, then equation has no roots. Okay. Now let's try our hand at a new equation. Okay. So let me write it. Our new equation looks like this, somewhat. So our new equation looks like x square minus 4x plus 4 equal to 0. Now if I once again take the values a equal to 1, b equal to minus 4 and c equal to 4, and once again I will try to plug it in the quadratic formula, that is x equal to minus b plus minus square root of b square minus 4ac by 2a, which is equal to 4 plus minus 4 whole square minus 4 into 1 into 4 whole divided by 2 into 1. This will then come out 4 plus minus 16 minus 16 divided by 2, which then comes out 4 plus minus root of 0 by 2, which is equal to 4 by 2 equal to 2. Now as we see that in this particular equation we just got one value, because 4 plus 0 and 4 minus 0 both yield the same result, that is 4 by 2 equal to 2. So what we realize is that despite having two roots, this has only one solution. So as discussed earlier, this equation has two roots which are 2 comma 2, that is two equal roots. So from here comes our next statement, that is if b square minus 4ac, if this particular value becomes 0, then in that case we will get equal roots. So if b square minus 4ac equal to 0, roots are equal. Similarly, if b square minus 4ac is greater than 0, then roots are not equal. So we get our three conditions depending on the value of b square minus 4ac. So the crux of the matter is that just by looking at the value of b square minus 4ac, we can tell that the equation has no roots, equal roots or unequal roots. Fine. Signing off on MIDP